All right. Well, how's everybody? Good, good, good. Okay, couple of housekeeping items for you. Let's see. So this coming Friday morning, the 26th, by 8:05, that is the deadline if anybody wants to retake the system of equations quiz from this past Thursday. You have to have both the substitution and the elimination assignments both completed before you go ahead and retake. Let's see, yesterday we talked about systems of inequalities. I gave you the homework. That'll be due tomorrow, so it'll be the first thing we talk about tomorrow. That we have a quiz on that on Thursday, so we want to be looking ahead to that. And then hopefully everybody's got this marked down, or at least remembers, next Thursday, October 2nd, that's going to be the second exam. So that one's going to be our second CFA, Common Formative Assessment. So go ahead and please bring your charged Chromebook that day because it's going to be online. And I'll be reminding you as we get closer, all that good stuff. All right, so that's all I got unless anybody has any questions. Okay, well, very quickly, let's go ahead and take a look. We were discussing systems of inequalities yesterday, and I asked you to go ahead and finish up with, I believe it was this number 9, correct? Yes. Okay. So Greg needs at least $1.60 in stamps to mail a package. He has 28 cents and 4-cent stamps. He can use no more than 24-cent stamps, as he has only one book left. So write a system of linear inequalities to represent the situation and then graph it. So what I did, I said X is the number of 28-cent stamps. Y is going to be the number of the 4-cent stamps. Okay. Well, it says specifically he can use no more than 20 of the 4-cent stamps. So that's where I got my first inequality from. So Y has to be less than or equal to 20. Okay. And because we are given $1.60, that's where I got the second one. You'll notice I didn't use decimals, though. I just multiplied that through by 100. So 28x plus 4y greater than or equal to 160. When I did a little bit of algebra, that came out to a negative 7x plus 40. Both had equality. Both are solid lines. And this is the region where I was shading. Okay. How many folks had the opportunity to try that last night? Okay, thank you. That's a lot of hands going up. I appreciate that. And then I don't have anything written for Part B. The reason is because answers are going to vary. All you have to do for Part B is just choose an ordered pair from somewhere in the shaded region that would make it a true statement. All right. And technically, we should be restricting ourselves to quadrant 1 because we're talking about money, a specific number of items. But did anybody have any questions on that? Okay, everybody's good? Okay, well, that makes that easy. Then what we're going to go ahead and do, actually what we're going to be spending most of this week on is now going to be solving 3x3 systems in 3 variables. Okay, so let me go ahead and pull this up. Okay, so I'm going to go ahead and give you a disclaimer before we go ahead and get started. Solving these by hand, it's not difficult, but it can be time consuming, especially how you decide to work the problem. So I'm just going to go ahead and throw this out there in the beginning. It's going to take us several minutes to get through one problem, and that's okay. So we just want to practice. That's the only thing. So let's run through these steps. Number 1, choose 2 equations in which you could easily eliminate a variable. Let's call this new equation after the elimination equation A. 2, eliminate the same variable from a combination of the equation you didn't use and one that you did. Let's call this equation B. Put equation A and equation B together, solve that system. You now have 2 of your variables. Then we're going to go ahead and start to substitute back into your originals. So the idea is we're starting with a 3x3. 3 equations, 3 unknowns. We basically want to manipulate it so that we only have 2 equations and 2 unknowns. We want to rewrite it into something that we've been solving recently, and then we can start working backwards and figuring out what our values are. But I want to go ahead and show you very quickly, when we have something like this, ax plus by plus cz is equal to d, where a, b, c, and d are just real numbers, this is no longer a linear function. Can anybody actually tell me what this represents? This is going back to geometry. A plane, there we go. It's a flat, two-dimensional surface that extends forever in every direction. So what we're looking at when we're solving a system like this is the intersection of three planes. And there's a lot of different ways they can interact. So I came up with these images here. These are way more than I could ever draw by myself. So for example, the one at the top left, this would have no solution to it. Why would that be? The planes are not intersecting each other. So the solutions depend on where all three of your planes are intersecting. If I go ahead and take a look at the one in the middle, all three planes are intersecting in a what? In a straight line. If this is the case, there's an infinite number of solutions. Any point on that intersected line, that's going to be a solution to our system. Okay? What do you think about the top right? That's no solution. Now, there are a couple, like, for example, the plane in yellow and the plane in red. They have an infinite number of solutions, but you're looking for all three. So this one is no solution. What about the bottom left? That's no solution as well. What about the bottom right? That's a single point. All three of these planes intersect in a single point, so right there you have one solution. Now, the thing about a 3x3 system, it's no longer an ordered pair. We call it an ordered triple. So it's going to be looking like this, X, Y, and Z. Okay. Other than that, it really just boils down to the algebra and your ability to solve and manipulate equations. Okay, so let's go ahead and get right into this. Okay, see how many of these we can do. So number one, I've got 2x minus 6y plus 9z is equal to negative 8, 5x plus y plus 2z equals 10, and 3x plus y minus 8z is equal to a negative 28. Okay. Here's the idea. First thing I've got to do is choose two different pairs of equations, and I want to eliminate the same variable. Here's what's nice about this. You can eliminate whatever you want. You can eliminate the x's, the y's, or the z's. Okay. It depends on what you want to get rid of and what's going to happen as a result of that. I would go ahead and say, let's eliminate the y's in this first one. Because you'll notice the bottom two equations, they're already y and y. I can easily subtract those and be done with it. Okay, so let's do this. Let's go ahead and say that I'm going to work with the first two equations. Let's call that A. And then the second two equations, let's call that B. This is what the set of instructions was telling us. We want to choose two different pairs of equations, and then we want to eliminate the same variable. Okay, so I'm going to go ahead and take these top two. 2x minus 6y plus 9z is equal to a negative 8. And then we have 5x plus y plus 2z is equal to a 10. Okay. Now remember, it doesn't matter if we end up with the same coefficient or opposite coefficients. That just depends on if we're going to add or subtract. If I want to eliminate the y's, an easy way to do that, well, what if I just multiplied the second equation through by 6? Okay. So I'm going to have 2x minus 6y plus 9z is equal to a negative 8. Now, if I go ahead and multiply the second one through by 6, that's going to give me 30x, okay, plus 6y. Then I have plus 12z, and then it's going to equal 60. Is everybody with me so far? Okay. It's exactly what we would have done before. It's just slightly larger. That's it. Okay. Now, what am I going to do here? Am I going to add or subtract these? We're going to add, because see, the way I set this up, I have opposite coefficients on the y's, so we're going to add them. We subtract if they're the same coefficient. So I'm going to add these. So let's see, I need a 2x plus 30x. 32x. Those y's are going to cancel. I need a 9z plus a 12z. Plus 21z is equal to, and then negative 8 plus 60, that's a 52. Okay. So that's a brand new equation, but with only two variables. Okay. Now you'll notice that's what I referred to as equation A. Now the bottom two, we're going to do the exact same thing. Okay. So I've got 5x plus y. Then I've got plus 2z is equal to 10. Then I've got 3x plus y minus 8z is equal to a negative 28. Well, this one, I don't have to manipulate one or both of the equations. I still want to eliminate the same variable. So here I'm just going to subtract. Because y minus y, they're going to cancel. So how many x's do I have? Yeah, 5x minus 3x, that's going to give me 2x. Now here's where you got to be careful. Remember, we're subtracting a negative. So 2z subtracting a negative 8z. How many z's do I have? Positive 10z equals, and then I'm going to do the same thing here. 10 minus a negative 28, positive 38. Okay. So you see what I've done? I've taken two different pairs of equations. I eliminated the same variable. Now I've got a system that we're already used to solving. So 32x, this will let me write this. 32x plus 21z is equal to 52. And I've got 2x plus 10z is equal to 38. See, now I want to solve this system. Okay. So this is what I was trying to tell you about at the very beginning. It's not difficult. It's just more time consuming than anything. Okay. But look at the bright side. I mean, you're doing math, so there's going to be a smile on your face, right? Okay. Now from here, I've got two equations and two variables. I can go ahead and eliminate whatever you'd like me to. Would you like me to eliminate x or z? Let's eliminate the x. Okay. So let's see, I've got a 32x and a 2x. How would you recommend I do this? Okay, let's go ahead and multiply the bottom by 16. Now you'll notice, you probably already figured out, that's why I've got these little scientific calculators out here to help you with those calculations. Okay. Because I know that people were going to enjoy the strategy so much. I didn't want you to get bogged down in that stuff. But you'll notice I don't have the inspires out because I did teach you to what? We could solve this using what type of matrix? Starts with an I. An inverse, okay? But I want you to be able to do this by hand as well. Okay, so this top one we didn't touch. So 32x plus 21z is equal to 52. And let me go ahead and turn on the light because some of these are solar powered. So we need some light. Okay. So let's see here. If I distribute the 16, that's going to be a 32x plus, well, what's a 10z times 16? 160z, okay, is equal to, now for 38 times 16, I'm getting 608. Let's type that in wrong. 38 times 16, 608. There we go, 608. There we go. Okay. So now that I rewrote it so that I have the same variable, I'm going to subtract those. Okay. So I'm looking for a 21 minus 160. Negative, what's that? 139z equals, now I need a 52 divided by 608. Did I say divided by? 52 minus 608. There we go. Negative 556. Now I need to divide this by 139. What do I get? Z equals 4. There we go. See, I rewrote the 3 by 3, so it's a 2 by 2. I solved the 2 by 2. I have my first variable. Now I start to backtrack. I'm going to take this first variable, and I can go ahead and plug it into either equation that contains x and z. So I'll find x, then I'll use x and z to find y. and we'll have our ordered triple. Okay, so what would you like me to use, the top one or the bottom? Okay, let's use the bottom. So this is going to be 2x. Okay, then I got plus 10z, so this is plus 10 times 4 equals 38. Okay, so let's see, 2x plus 40 is equal to 38. So it looks like 2x is equal to a negative 2. So what's x? Negative 1. See, once you find that first variable, then it goes a lot faster. Okay. Now all I got to do is find what? I got to find y. And I've got 3 different equations to use here. First, second, or third? Which one would you like? Second, okay. So 5x plus y plus 2z. So 5x plus y plus 2z, and I believe that equal to 10. Is that right? Okay. So let's see. If I go ahead and plug negative 2 in here, that would be a negative 10 plus y. Then if I plug that positive 4 in here, that's going to be plus 8 is equal to 10. Okay, so negative 10 plus 8 would give me negative 2 is equal to 10. So what am I getting for y? Wait a minute, did I make a mistake? Negative 10 plus y plus 8. Was it equal to a negative 10? Oh, I even wrote it there. Yeah, so I got a negative 10 here. So that's a plus 2. Why did I do that? Oh, daggone. Okay. I was looking at this right here. Daggone. Too much stuff up there. So that's going to be a negative 5. My fault. So negative 5 plus y. Okay, so that is going to give me y plus 3 is equal to 10. Yep. So y equals 7. There we go. So x is negative 1, y is 7, and the z is 4. So there is my ordered triple. So this is what I was trying to get you to see at the beginning. It's going to take a few minutes to get through it. Okay. Yeah, big. To want to do the original problem? Well, see, here's the thing. See, if I know z, that still leaves me 2 unknowns. So I'm going to go ahead and start to work backwards. I'm going to plug it into an equation where I could find the other variable, and then I could use that to find the third. Okay. All right, yeah. Yes, this one right here in the middle. We specifically chose 16 because we wanted to eliminate the x's. 16 times 2 gave me 32. See, I wanted to match it up to the other coefficient. Okay. All right. So just a little bit of work. That's okay. Not a lot, right? Okay. So let's try another one of these. And at least I'm thinking about you, right? I mean, the other Algebra 2 teachers, they're wanting you to go ahead and do all this by hand. And I said, okay, that's a bit much because it's already going to take a while to solve the problem. So let's at least give them some scientific calculators. Unless you want a real challenge, then I do it by hand. I do what I can. I do what I can. I do what I can. All right, let's try this number 2 right here. Okay. So let's see. I've got 4x plus y minus 3z equals 45. 6x minus 4y plus 3z equals 41. And then 2x minus 7y minus 11z equals 85. Okay. I will let you folks take the lead on this one. Do we want to get rid of x, y, or z? X? Okay. I've heard a couple of y. Let's go ahead and put it to a vote just to make sure. How many want the x gone? Okay, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay. How many want the y's gone? 1, 2, 3. And what about the z's? We got 1, 2, okay? So it looks like we're going to go with the x's. Now, here's the thing. Here's the thing about this. If you were one of the people who raised your hand to eliminate y or z, I would encourage you to go ahead and do that. Why would that not make a difference? You're still going to what? As long as your algebra is correct, you're still going to get the right answer. Okay? It is completely up to you. Okay? Now, what I would probably do is let's go ahead and compare the first one and the last one. Let's go ahead and say that's A. And then let's compare the second to the third. We'll call that my B. Because if I were to go ahead and say compare the first to the second, and I wanted to get rid of the x's, I'm having to multiply both equations. I mean, that's very doable, but we also don't want to give us more work than is necessary. So I don't know why I turned that off, because we need light. Okay, so let's start with this first one. I've got 4x plus y minus 3z is equal to 45. And we're going to compare that to 2x minus 7y minus 11z is equal to 85. And we decided we want to go ahead and get rid of the x's. How would you do this? Let's multiply the bottom by 2. Okay. Alrighty, so I'm going to multiply by 2. So this is going to give me the first one we didn't touch. So 4x plus y minus 3z is equal to a 45. So now if I double this equation, I'm going to get 4x minus 14y minus 22z. And this equals. So that would be, what, 170? Okay, there we go. Now, because we decided to make the coefficients the same, we're going to subtract these. Okay, so those are going to cancel. Now, remember, we're subtracting a negative. So y minus negative 14y, how many y's do I have? We got a positive 15. So positive 15y. Now I need a negative 3z plus 22z. Positive what? Ooh, a little off. Oh, 22. 19. I was thinking 21. And this equals, and then I need 45 minus 170. What should I get? Negative 125. Okay, so there's my first equation with only 2 variables. Okay. All right. Now let's go ahead and set up the other 2. So I've got 6x minus 4y plus 3z is equal to 41. And we've got 2x minus 7y minus 11z is equal to 85. Okay. So how would you recommend I do this one? Let's multiply the bottom by 3. Okay, dokie. So we got 6x minus 4y plus 3z is equal to a 41. So that's going to be 6x minus 21y minus 33z is equal to, what would that be, 255? 255. Everybody okay with what I've got? Okay. So now let's subtract. We have the same coefficient. So let's see here. I need a negative 4y plus 21y. Positive what? 17. So 17y. Then I have a 3z plus 33z. Okay. What's that? 36. Z is equal to, and then 41 minus 255, negative 214. There you go. All right. So now we've got my 2 by 2. Okay, question so far. Okay, let's put them together. So 15y plus 19z is equal to a negative 125. 17y plus 36z is equal to a negative 214. So what would you like to eliminate now? The y's or the z's? Want to get rid of the y's? Okay. So in this case here, I'd probably just go ahead and multiply the top one by 17 and then multiply the bottom one by 15. Because that's going to go ahead and definitely give me the same coefficient. Everybody agree with that? Okay. And don't let it bother you that we're going to get these large products because we got our scientific calculator, so we're good to go. So 15 times 16, I got 255. Okay, so 255y plus 19 times 17. Oop. I got 323. Z equals 125 times 17. I got 2,125 negative. Okay, so those numbers looking familiar? Okay. Now we multiply through by 15. So again, I got 255y. 36 times 15. I got 540 plus 540z is equal to negative 214 times 15. And what should I get for that one? 3210. Okay, and it's negative. Okay. All right, those numbers looking familiar? Okay, don't let them bother you that they're huge. That's okay. Got the same coefficient, so I'm going to subtract these. Those are going to cancel. So 323 minus 540. How many z's do I have? Oh, I got negative 217. Because remember, the 540 isn't negative, so we're not changing it to addition. Okay, so I got negative 217z equals. Now for the other one, we're subtracting a negative 3210, so we are going to add that. So 3210, 2125. I'm getting 1085. Is that what everybody's getting? Now we need to divide through by 217 negative. Okay. What's z? Z equals negative 5. Now we had to go through some horrible values, but it turned out nicely. I will go ahead and tell you that all the examples here, because this is the first time we're looking at this, they're going to turn out nice. They're going to be integers, okay, whether positive or negative. Now, does that mean we couldn't get decimals or fractions? Could. That's where the fun, but nothing right now, so it's okay. Don't worry. All right, so I've got z is equal to negative 5. What do? Now we need to go ahead and start working backwards. Okay, so I've got two equations containing y and z. Okay, which one would you like me to use? Top one, bottom one? Top one, okay. So that's going to give me 15y plus 19z. We found z to be negative 5. Is equal to a negative 125. And see, now we're just solving an equation for a single variable. Is that okay with what I'm doing? Okay. So 19 times negative 5. So we got 15y minus 95 is equal to a negative 125. Okay. So what is a negative 125 plus 95? Okay, what kind of 30? Negative 30. And now we know that y is what? Negative 2. See, once you find that first variable, then it ends the problem pretty quick, because all you got to do is plug in and simplify. So z is negative 5, y is negative 2. All we have left is what? X. Okay. So let's come on up here. What would you like me to use? Top, bottom, or middle? Middle? Middle's the first one I heard. So we have 6x minus 4y plus 3z is equal to 41. Okay. We just found z is -5 and y is -2. So 6x minus 4 times -2 plus 3 times -5 equals 41. And then now it's just a matter of working through that. Let's see here. 6x plus what? 8 minus 15 is equal to 41. I need an 8 minus 15. 6x. 8 minus 15. -7 is equal to 41. So 6x is equal to 41 plus 7 will give me a 48. So what am I getting for x? 8. Can anybody try it one of those different ways we talked about and get the same thing? Okay. So my final answer, the ordered triple, is 8, a -2, and then a -5. There we go. Okay. See, if you go ahead and take a look, you know, we're almost done with class, and we've only done 2 problems. Okay. So it's not difficult, it's just monotonous. It just takes some time. Definitely not something you want to rush through. Okay. Any questions so far? How are we doing? Yeah. Actually, it depends on what you want to eliminate. Whatever you think is going to be easiest to start out, that's what I would always start with. Like, I'm actually surprised that no one, I think only in here, what, 1 or 2 people said Z? Because if you go ahead and take a look, you'll notice you've got a -3z and a +3z. I could have immediately combined those and immediately had an equation. Okay. But I mean, it just depends on whatever you want to do. Does not matter. There's a lot of freedom in solving these problems. Okay. Well, let's try another one. Okay, get all this erased. Okay, so number 3, here we go. So 5x minus 3y plus 8z equals -59. 9x minus 4y minus z equals -60. And then a 5x plus 2y plus 4z equals -47. Okay, so I'm going to let you folks completely direct me on this one. Okay, so we've already seen a couple of these. Okay, so let's go ahead and try one more. Hello. Okay, so what would you like me to eliminate? I want to eliminate x. Okay. So what 2, let's go ahead and say going from top to bottom, it's 1, 2, 3. What equations would you like me to group? 1 and 3. So 1 and 3, let's go ahead and call that A. And then what's the other 2? We could do 1 and 2 or 2 and 3. 2 and 3, okay. So let's make that our B. Okay. So let's go ahead and stack them. Let's see what we got. So 5x minus 3y plus 8z is equal to a -59. And we're going to put that with 5x plus 2y plus 4z is equal to a -47. Okay. Now I can already see why you went ahead and chose this one. All we have to do is what? Subtract. Okay, we're going to get rid of that x right there. So let's see. Those are going to cancel. So now we've got a -3y minus 2y. So that's a -5y. Now I've got a 8z minus 4z. So that's another 4z. Okay. Now, -59, remember we're subtracting a negative, so what happens? It goes positive. Okay. So -59 plus 47, what's that going to equal? -12. Okay, so there's my first equation. Everybody's okay? All right. So now we're going to go ahead and take the second and third. So I got 9x. What do we got here? Minus 4y minus z is equal to a negative 60. And we got 5x plus 2y plus 4z is equal to a negative 47. Okay. So if we want to eliminate the same variable, we got a 9 and a 5. How am I doing this? Multiply the top by 5, multiply the bottom by 9. Sounds like a plan. Okay, so by 5 by 9. Okie dokie. So let's see here. That's going to give me 45x. What? Looks like that's a decimal. Okay, so then I'm going to have minus, 20y minus 5z. Now I need a negative 60 times 5, negative 300. Okay. Now we're going to multiply the second one by 9. So that's going to give me the 45x we're looking for. Okay. Plus how many y's? Oh, 18 y's. Plus how many z's? 36z. Now I need a 47 times 9. Negative 423. These numbers looking familiar? Okay. Now, because we made the same coefficient, we're going to go ahead and subtract these. Those are going to cancel. Okay, here we go. I need a negative 20y minus 18y. Negative 38y. Okay, negative 5z minus 36z. Negative 41z. Okay. And then I got a negative 300 plus 423. 123. Okay. Questions? Anybody having a hard time? Okay. All right. So now I'm going to take these two new equations. We whittled it down to a 2 by 2. Let's go ahead and stack those. So negative 5y plus 4z is equal to 12. And then we got a negative 38y minus 41z is equal to 123. Okay, so I've got to choose another variable to eliminate. Okay, how about Kareem? What would you like? You want to get rid of the y's or the z's? You want to get rid of the y? How am I going to do that? Let's multiply the top by 4. Okay. 5. Now, the way I'm doing this, we're going to have to subtract them. I could put a negative on one of these. Elliot. Oh, is it time? Okay. All right, have a good one. All right, so everybody agrees what we're doing? Okay, so let's see. 38 times 5. Whoops. Okay, so I'm getting a negative 190y. Okay, then I need a 38 times 4. 152. Z is equal to, and then 12 times that, 38. What am I getting? Negative? Oh, that was a 12 negative right there. Yeah, negative 456. I didn't carry that negative down when I rewrote. Okay. All right. And then we already know that 5 and a negative 38 will give me a negative 190y. Let's see, 41 times 5. We're looking at a negative 205. Z is equal to 3 times 5. What am I looking at? 615. Okay. Questions? Okay, so we're almost there. We're in the home stretch. We're about to solve for Z, and then we can start working backwards. So I'm going to subtract these two. Subtracting a negative makes opposites. Okay. So it looks like I'm going to have 152z plus 205z. So that's 300 what? 357z is equal to, now I need a negative 456 minus 615. 1,000. Okay, 1,000 and what? Okay, 1,071. And that is negative, of course. There we go. Okay, all we got to do now is divide. Okay, so I'm getting C is what? -3. See, for all that work, it turned out super nice to us. Okay. Now where the problem is going to finish up pretty quick, which is good because we got about 5 minutes left. So let's come on back up here. Now that I have Z, I can use one of these equations to go ahead and find Y. Which one would you like? The top one? Okay. So let's see here. That's a -5Y plus 4Z. Okay, we found that to be -3 equals -12. So -5Y minus 12 is equal to a -12. So what's about to happen? What's -5Y going to equal? 0. We're going to add opposites. So what happens here? Y's got to be what? Y's got to be 0. Still going to go ahead and divide through by that -5. So I got Y as 0. All right. I got Z. I got Y. Now it's time for what? X. Okay, so I'm coming on back up here. Let me go ahead and give myself some room. Okay. Let's see here. Joseph, what do you think? 1, 2, or 3? Which equation would you like to use? 1? Okay, so 5x minus 3y plus 8z is equal to a -59. Okay, we can actually just go ahead and immediately just not even worry about that -3y because remember y was what? Y was 0, so that term disappears. I believe we found z to be a -3. Okay, so 5x plus 8 times a -3 is equal to a -59. Okay, so that's a -24. If this board would let me write, equals a -59. So I need a -59 plus 24. -35. So 5x equals a -35. So I've got that x is what? X is -7. So we have -7. We found y to be 0. And we found z to be -3. Boom. There we go. So it took us pretty much the entirety of the period, but we got through 3 examples. What do we think about these? Easy? Okay, I like that. Okay. See, they're not terrible. They do take up a lot of space. You do want to be careful with the calculations. Okay. But we're going to go ahead and continue to work this tomorrow. Remember, what's due tomorrow? The homework for systems of inequalities, because you have a quiz over that on Thursday. There we go. Cool. All right, if you'll go ahead and get those calculators back up to the front, please. All right. Go ahead and get this out of the way. Stop this recording.